Hello, can you hear me?
Yes,
Okay, so how are you?
fine, thanks. And you?
Okay, I'm fine, thank you. Okay, so let's go. We'll start. So, which topic is not completed, such as ocean current, how we can easily monitor, then potential fishing zone, how we can easily monitor, or ocean salinity, as well as also ocean turbidity, how we can easily monitor. So, step by step, I will try to show you that all of example. Then I hope we can easily apply this type of code for your own study area. Okay, so let me share my screen. Can you see my screen?
Yes.
So let's go. So let's go start. Yeah. Okay, so first of all, I will try to explain about that how we can easily monitor the ocean turbidity. So in this course, I already make the code for the whole ocean, all of ocean. Okay, so you can see all of water body we consider for the whole ocean, and then we try to monitor for turbidity. Okay, so if you check that the result, we find out that near to the coastline, okay, we find out that high turbidity. Okay, always you can see near to the coastal line, this type of place, we find out that turbidity value is very high for this type of region. Also you can see this type of region, we find out that high turbidity near to the coastal line, or also you can see this type of region also in here. Okay, this type of region, it's a high turbidity region we find out. Okay, so now how I can monitor this type of things, I will try to explain. So it display for the global, okay, global all ocean we try to add in here, and then we further monitor for turbidity. Okay, so this turbidity is generated by using this data. So this is the ocean color data, we already know about that. Ocean color, SMI, standard mapped image, modis aqua satellite. So this data we find out that lot of information. Okay, so if you check it, we already learn about that chlorophyll. Chlorophyll basically it's in uh, get the information about that chlorophyll concentration. Okay, it also available for that ocean chlorophyll, we can easily monitor using this band, we already know about that. As well as it also provide you this type of NFLS, normalized Florence line height, we also monitor using that. Or particulate organic carbon. Okay, particulate organic carbon, if you want you can also monitor particulate organic carbon using this band POC, this is the band about that. As well as it also provides some band, you can see remote sensing reflectance at band 412 nanometer. Also you can see remote sensing reflectance at band 443 nanometer. So it also provide you different types of band, okay, for remote sensing reflectance at band 488 nanometer. So now from here we need to identify two band, basically red band and near band reflectance. Okay, so if you check it, suppose what is the reflectance in the red band and near infrared band, what is the range about that reflectance, then we find out that the RS 645 and RS 678, these two band is near infrared band and red band reflectance value range. So if you check it, this type of band, we find out that 469 nanometer, 488 nanometer reflectance, 531 nanometer reflectance, 547 nanometer reflectance, 555 nanometer reflectance. So red band and near infrared band reflectance value 645 for red and 678 for near infrared. Okay, so this is the value for reflectance value for MODIS we find out. And now I want to monitor, suppose I want to monitor it for year of 2022, January to December. So I take the whole year or annual 1 year data, annual 1 year data we try to consider in this time, and then filter bounds without study area. So in this case I take the whole water body, okay, whole ocean. So for this is the things I put in here, so it consider about the whole ocean. Suppose you need for a specific boundary or a specific area, then you can simply draw the study area. Suppose I need the result only for this boundary. Suppose I need the result only for this water body, only for this water body I need, only for this lake. So for that you can simply draw the study area. Suppose I simply show you that. Suppose just I draw this study area, look like that. And further I simply take a geometry and I just put here, it's my AOI. Just I put here AOI. So now this result I find out for this AOI. If I run the code, so then we can get the result only for this AOI. If you check it, so we find out that only for this AOI we find out, okay, not okay, sorry, it's not clip. So just we need to clip after calculating this median. Okay, just I put here dot clip, okay, dot clip with study area AOI. So now run the code. So now we find out the result only for our study area which I selected in here. So now you can see we got this type of result, but this result is not look more better because in this case it show the default visualization. If I just stressing the data, suppose if I just stressing data 98%, so then we find out that more better visualization. Just apply it. So now we find out that this type of value. So now you can see we can easily find out this type of result. So this type of red color indicating about that high turbidity region. This type of red color indicating about the high turbidity region, and this type of blue color it's indicating about that low turbidity region. So then yellow and red it's medium or moderate, this type of place we find out. So if you just zoom, then you also get the more better idea. So you can see this type of place or this type of red color pixel indicating about that high turbidity region, okay, and this type of place is indicating about the low turbidity region, okay. So now how I can calculate the turbidity? So in this case we are just apply a empirical coefficient, okay. So empirical coefficient, so if you check this type of formula, so this is one kind of formula. This formula we try to apply in here. So it's one kind of empirical equation. So we can also adjust this for our specific boundary. So when you adjust with your specific boundary, then we need the ground truth data. So in this case, this value you can see in this time A is one value and C is another value. This A and C, it's called the empirical coefficient, okay. This empirical coefficient, it depend on the ground truth data, okay. A and C, these two value, it depend on your ground truth data. So in this case I take the normal. Normally I take this I check some paper, reference paper, and further I find out the A and C value belong, so then I take this value normally. But when you want to take for a specific water body, then you must need the ground truth data to generate the empirical equation as well as also generate the empirical coefficient, okay. So this empirical coefficient you just simply put in here A and C value, and then we can easily apply this formula and calculate the turbidity, okay. So now this is the turbidity collection we find out in here, and then we just simply visualize. In this case I try to calculate for median value of turbidity. If you want, you can also write here average. Suppose when you calculate average value, then simply put here the mean, okay, mean function. So in this time I take the median, I take the middle pixel value of turbidity between my time period and select the turbidity band and then clip with my study area. Then we can easily get this type of result. So it's one kind of way to calculate the turbidity using this empirical equation. But when you apply this equation for your specific boundary or a specific water body area, then you must take the ground truth data and calculate the empirical coefficient, and also then this coefficient simply put in here A and C value, and this RRS, so it's one, this is the band, okay, this is the red band, okay, this is the RRS 654, it's come from satellite sensor, okay. And then we can easily calculate this type of turbidity, and we can easily identify where is the high turbidity value, where is the low turbidity value of water, we can easily identify. So any study area we can simply use the same process. Suppose I need the result for another study area, so just let me remove my previous AOI, just I remove. Suppose I need this result for this for this ocean. Okay, for this ocean I need this result. So for that, just take the study area, just take a AOI, just simply draw this AOI. Suppose this is my study area, I simply draw. And now further, just put here AOI and then run the code. So now we can easily find out this result. What is the scenario of this ocean turbidity? We can easily find out from here. So we find out this type of result, but when you just stressing, suppose in this case I keep stressing 90% and then apply. So now it displays the result. We find out, you can see this type of place, it's indicating about the high turbidity. Okay, this type of red color indicating about the high turbid region, we find out. Okay, as well as also you can see near to the coastline, we find out the high turbidity, this type of place. And this type of place, it shows the normal turbidity. And this is the result for year of 2020. Okay, basically this data set, we find out the data from year of 2002. Okay, so from year of 2002 to 2022 or 23. Okay, this type of data is available. So then you can easily monitor between this time period. Between this time period, you can easily monitor any data set, you can easily do. Okay, so this is the one way to turbidity we can easily monitor. Okay, so this is the way for turbidity. But in this case, when you apply this code for your own study area, if you have the ground truth data, this ground truth data you just simply use and then calculate the empirical coefficient and further use it, then you also get the more better result. But normally in this case I take this type of value, but this value is not fixed. Okay, it need to adjust for your study area. Okay, but reference paper, you also check some reference paper. Okay, then you try to take the decision and take this type of value. Okay, so any question please for turbidity?
No, it's okay. I need
Okay,
to
okay.
find references from
Yes. And
close
further,
to
if you
me.
want, you can simply export this map. Just use the export image to Drive and then put all of those. Then you can easily export this type of things. Okay. So then I try to discuss about another topic. Just a minute. Let me open. Okay. So this one, just a minute. Let me check the result. Okay, this thing we already know about that. Okay, so I also explain the code again, then you can easily get the more better idea. So this is the chlorophyll and sea surface temperature. Okay, just let me focus on my study area. Okay, so in this case, we try to create this type of chlorophyll and also create for sea surface temperature for this ocean. So this is my study area, and we try to check the trend. What is the trend about that chlorophyll? What is the trend about that temperature? Okay, so if you check the trend, so we find out that temperature is increasing. Okay, temperature is increasing day by day, and chlorophyll is decreasing. Chlorophyll mainly phytoplankton. Okay, phytoplankton on the water body. So chlorophyll, it indicating about that phytoplankton, and this is the temperature. Okay, temperature is increasing day by day in this study area. It's a sea surface temperature, and it's a sea surface phytoplankton or chlorophyll. Okay, so now in this case, how I can create? So in this analysis, I want to define my time period 2005 to 2020. Okay, so this is my time period, study area in year, and I take this is my study area, I take this is my study area as a ROI. So now in this case, I take the same ocean color data, L3SMI, standard mapped image. This data use same data, and this data already have the chlorophyll concentration and also have sea surface temperature. Okay, and then I filter bounds. We find out that total image collection 7084 image collection we find out in here. So this is the total image collection, and now I create, so if you check it, I create the annual time series. Okay, so it's a annual. Suppose in year of 2000 2005 average temperature, then in year of 2006 average temperature, then in year of 2007 average temperature. So in this code I create annual composite with time info. So I create it annual time period, annual average for chlorophyll, and also annual average for sea surface temperature. I just create. So how I can create? So this is the function for it. So in this function we just create a annual composite from 1st January to December 31. We create that start date and end date. Start date will be start from 1st January, and end date it will be start from the December 31. And then I call my collection data set. This collection 7084, this is my total collection. It is stored in the data set. So this data set I filter according to the time period, start date and end date, and I calculate the mean. And further I clip with my study area and I set the year, because I need the yearly set as property as the yearly. And then we just put here the return the time stamps and then return the annual composite. So then further we make the list. We are just make the list of year mainly year of 2005 to 2020. Just make the list, and this list we simply connect with our collection function. So just I call the years, and this is my function variable name. So just I connect using the map function. Okay, this is my function variable name. Just simply connect. So now it stored the annual image collection. So if you check it, so now we already add that all of year. So SST 2000, then chlorophyll 2000, SST 2019, chlorophyll 2019, SST, chlorophyll. So we just add all of layer together, and further we try to just create the time series and also trend line. Okay, trend line basically, if you can see it show the low trend. Low trend means that day by day chlorophyll is decreasing, mainly phytoplankton, due to the temperature. Because if the temperature is high, then we find out that phytoplankton or chlorophyll is low. Okay, so we find out that opposite correlation between the temperature is increasing but chlorophyll is decreasing. Okay, so we create the time series chart for that and create the linear. You can see we put here the linear type trend line. We try to add in here, and then we display the result for the trend line, chlorophyll and sea surface temperature. So this is the way, and I also add this type of things. You can easily export. Okay, yearly or annual sea surface temperature and chlorophyll sea surface temperature, you can simply download from here. So this is the another way to compute ocean turbidity, then chlorophyll and sea surface temperature. We can easily monitor using this way. Okay, so I'll also send you this video also to practice this type of work and also create the trend. Okay, so it's a annual trend between 2005 to 2020. You can also create the day trend or any trend we can easily create using the same way. Okay, not like this. Let me open. Okay, yes, yeah, this one. Okay, so now I talk about that how we can easily identify for potential fishing zone. Okay, so this potential fishing zone, basically these things we can easily do, and potential fishing zone is depend on different types of factor. Okay, so in this case, if you check it, for the identify potential fishing zone, we try to identify suppose sea surface temperature. Okay, so sea surface temperature is one kind of factor for potential fishing zone, because if the temperature is very high in the sea, this place we don't find the fish. Okay, so we need the optimal temperature for fish zone. Suppose this place we find out the very high temperature, so then we don't find out the fish in this place. So we need the optimal temperature for the fish zone. So then I simply take the data. So this is the ocean data, ocean color data. We already know about that. So from here we take the SST, mainly sea surface temperature we take. Then chlorophyll. Chlorophyll mainly phytoplankton. Okay. And phytoplankton is one kind of factor for food of fish. Suppose here we find out that high phytoplankton. So then this type of place we find out that high potential zone for fish, because fish for feed they feed the different types of phytoplankton on the ocean. So then we just, this is the another data, this data same data, this the same image collection we can take for chlorophyll. Okay, for monitoring that. So now we just based on the two data, SST and chlorophyll. Not only for that, if you want, you can also add here for salinity data, because salinity is important factor for water. So we can easily identify, suppose where we find out the high salinity, low salinity, what's the happen for fishing zone. So we can also add the salinity data, as well as also if you want you can also add here the turbidity turbidity data. So this type of data if you want, then it will be more strong for potential fishing zone. In this code I try to add for two information. First one is for temperature, second one is for chlorophyll. Okay, second one is for chlorophyll. We try to add in here chlorophyll, or it's also called the phytoplankton. We try to add in here. Okay, so now further in this case, I try to identify potential fishing zone time series analysis from 2015 to 2020. Okay, so we try to calculate 2015 to 2020 for potential fishing zone for different year. Okay, so here you can say I already classified for different zone from 2015 to 2020. So it's, this is the map, and we try to consider these two things. So this is my area of interest. This area of interest we try to consider, calculate the sea surface temperature. So if you check it, the sea surface temperature, so it's loading. Okay, let me run the code again. I think some networking issue. Okay, it's loading. So here yellow is the high chlorophyll or phytoplankton area. It's indicating.
You are not sharing your screen.
Okay, just a minute. Okay. Now can you see my screen?
Yes.
Okay. Okay. Okay, so here yellow is indicating about the high chlorophyll and blue is the low. And this is the temperature. I see some press temperature. So this is the two factor we try to add in here. But if you want, you also add the more factor and then classify it. So in this case, we try to classify it for different year. Okay, different year. What the scenario for the potential fishing zone. Okay, so then okay, so let's go. This is the data we try to add in here. So now we just process the data. So monthly process we try to for this data for just monthly SST data and chlorophyll data. So then further just we try to apply a SST update mask greater than 26 and less than equal 30. Okay, so in this case we try to put the SST basically sea surface temperature greater than equal 26 to and less than equal 30. So we consider this is the optimal range. This is the optimal range for the fish. Sea surface temperature greater than equal 26 and SST less than equal 30. So we just consider this is the standard man for the standard value for the ocean fishing zone. Okay, so you can also change this type of value for your own study area to identify suppose for that optimal temperature for fish zone. Okay, then you consider it. Or if you have some historical data, so this place suppose historical data I find out that this place always we find out the fish, then you try to check the temperature. Suppose I find out the temperature is the 26 greater than equal and less than equal 30, so then I simply apply 26 and less than equal 30 and I can easily identify this place is the high potential zone. And then for the chlorophyll we just put the greater than equal 0.05 and less than equal 3. This range we consider this is the standard value for chlorophyll for this study area. But you also try to check for your own study area what happened. Okay, what is the optimal value, what is the optimal value for chlorophyll, and this value we find out the fish, and what is the optimal temperature, and this temperature we find out the fish. So then just change it regarding to your study area, and then we just combine, just we try to combine these two things basically SST and chlorophyll we try to combine. And further we make the some classes you can see here. So we just make the classes, three class we find out in here after combine. So SST less than greater than equal 26 and SST less than equal 30, chlorophyll 0.1 and chlorophyll less than equal 3, we make a one class. Okay, same as for we SST 26 greater than equal 0.05 and greater than less than 0.01 for chlorophyll, we make the another class. So this is the high potential zone you consider, you can see. So 26 less than equal greater than equal 26 and less than equal 30 and 0.1. So this condition we consider it's an optimal condition. Okay, so that's why it's a high potential zone. And then this is the another one. So this condition we consider it's a medium. Okay, medium. and the others very low. So basically there are the total 3 class. If you check it, suppose if I just open this potential zone map, so we find out this type of color. So here red is indicating about that high potential zone, this type of place we find out the high potential zone, because this type of red place we find out that sea surface temperature less than equal 26 and sea surface temperature less than equal 30, okay, as well as chlorophyll 0.1 less than equal 0.1 and chlorophyll greater than equal 3. So it maintains, suppose this type of place, this type of red color, it maintain this, it maintains this condition. So that's why this type of place it show the red color and it indicating about the high potential zone for fishing. And others, if you check this type of blue color, it's the medium, not much high, okay, because it considered this type of place. So now you can simply check this type of place, then we find out the must fish, then this type of blue color, okay, because it mentioned this type of things. Suppose if we want to add the salinity, so then same process, we just make a condition for salinity, okay, just write in here for filtering the salinity, suppose greater than 0.12, greater than less than 0.5, this is that this type of range we try to put in here, or turbidity. Not only for that, there's a lot of factor, okay. So if you increase the different types of factor on your map, then it will be more good for identify for more potential fishing zone, okay. So in this case, for the example, I try to add for only for the two, sea surface temperature and chlorophyll. But further, if you want, you can also add here the turbidity. If you want, you can also add here suppose salinity, water. So different types of factor we try to add in here and create the same process. Process is the same, but we need to add different types of factor to identify for potential fishing zone. And further, just simply export all of layer. So I want to export suppose 2015 or 2020. So this type of things we just simply export, and further we can easily make the map using QGIS software or ArcMap software. So this is the basic process to identify for potential fishing zone using Google Earth Engine. Okay. Okay, thank you. Okay, so now we talk about that ocean current. So using the different types of surface current or ocean currents, we try to use. So it's one kind of website. Okay, so using this website, we can easily find out for present ocean current data. Okay, it provide you the present ocean current data. We can easily find out, and we can also check the ocean current information from this website. So you can easily find out for any study area, just simply zoom, and then you can easily check for the ocean current movement, ocean current, this type of info you can easily find out. Suppose I simply zoom, so you can see this type of place. We find out that very high speed, okay, density is very high. We find out this type of place. Also you can see this type of place. So red is indicating about that high speed of ocean, okay. Also you can see, suppose if I just focus on the Bay of Bengal, so you can see, and it show the present ocean current information. But when you see this type of place for the cyclone time or different types of hurricane, so different types of disaster, we find out this ocean current is very high. We find out. So you can see it show this type of things now. Okay, you can see we find out this type of place very high ocean current. We find out this type of place. Okay, also you can see this type of place we find out. So using these things, we can, it's very helpful for fishing zone also. Okay, because ocean current, this from this website we can easily find out for update ocean current information for the whole world. Not only for that, as well as we can also find out this is the another one, now cost. So this is the one kind of website. Okay, from this website we can easily find out more better information for, you can check you can easily add the different types of base map. Suppose if I just click on the satellite, then it show the satellite view or ocean view or imagery or OSM. So different types of things you can easily add. And you can see the layers, so we can add the active alert. So uh, active alert we can check. Okay, just I show you that all of one by one. So just I add. So yeah, this type of layer we can easily find out. You can see here, first one is the active alert. Okay, so now we find out this type of place, we find out the active alert. So this type of place now alert is active. Okay, you can see the gala warning. Okay, this place we find out the gala warning. Okay, and this is the coordinate. Suppose if I just click on here, so now it show about that flood warning. So this place we find out the flood warning. Okay, so it active alert. Suppose if I check, suppose this, click on here, so now it show about that present time small craft advisory alert. We find out it's close, just click, then you close. So it show the active alert. So if you click on here, it show the, you can see the gala warning or storm warning. Storm warning, this type of displays we find out storm warning. So this website is very helpful for identify for early warning system, because it use different types of algorithm and create the now cost, and we can easily identify for gala warning, storm warning, and you can check the different types of information. You can see in the time and date. Okay, 2025 5th April. Okay, this is the, okay, so this is a current warning, this type of place. Actual value, different types of expected event ending, you can see. Okay, 17. Okay, so this is the warning. It will be this expected event ending time 17 April. Okay, so now it's a current event. We can easily find out for globally, it's available for the globally. So now you can see this type of place, there is no current event. Okay, there is no warning, this type of place, this type of ocean, there is no event, there is no warning system now, because there is no alert now. But we find out this type of place, this type of place, also this type of place, there's a lot of alert. If you click on here, then you can get the more information about the alert. Gala warning, click on here, we find out that you can see the wind advisory. So different types of alert we can easily identify from this website. So it's the one kind of ready-made algorithm. It's very helpful to identify the early warning system and also get the different types of information. So this is the one way. So this is the active alert. And then you can see the blue topo. Okay, I think, okay, blue topo. Okay, just let me check. Yeah, so you can see the blue topo information. So blue topo and surface info. So we find out this is the elevation. You can see the negative. And it's basically show about the topography.
I can't hear you. I can hear you. I don't know why.
Can you hear me? Hello. Just a minute. Uh, okay, can you hear me now? Hello. Hello.
No.
Okay, just let me connect again. Okay, can you hear me? Hello. Hello.
If you are talking, I can't hear you.
Okay, I can hear you, but can you hear me?
You okay? But I
Hello.
can't hear you.
Okay, I think, okay, just you simply,
I don't know
okay,
why.
just a minute.
You are not mute. Just reconnect again, okay?
Okay, can you hear me now?
No, I don't know.
Okay.
So
So
what happened?